All right, everyone, let's have a look at worksheet number 7, questions 1B, C, and then question number 3. 1B goes back to the stem of the question. It says 3 charges in a straight row. The first charge has a value of 5 times 10 to the negative 5. Call that number 1. 5 times 10 to the negative 5 coulombs. The second charge is to the right of it, and it also has a charge of 5 times 10 to the negative 5 coulombs. We're going to say it's 0.025 meters to the right. And the third one, that's to the right of the second one, 2 centimeters to the right of the second one, or 0.020 meters. And the value of the third charge is negative 2.5 times 10 to the 5 coulombs. 10 to the negative 5 coulombs. We're looking for, in question C, we're looking for the net force on the third charge. So let's draw a free body diagram here. Remember, that's the first step. Yesterday, or Tuesday, as I was walking around between the 3 classes working on these questions, I had said to everybody, make sure you draw a diagram. And people, for the most part, follow that advice, but maybe not completely, because the diagram that a lot of people drew ended about like this. There's some value in drawing a diagram like this because it does show us our givens pretty well, but it doesn't show us the important part of this question, and that is which way the forces are acting. Draw a free body diagram. Show me the forces acting. Now, on number 2, we have 2 forces acting on number 2. Number 1 acts on number 2, and number 3 acts on number 2. You got to treat them independently of one another. So 1 acts on number 2, 3 is not even there. 3 acts on number 2, 1's not even there. Let's pretend 3 is not there. 1 and 2 are both positive. Did they attract or repel? Repel. Repel means push. Okay, repel means push. So number 1 pushes number 2. Okay, if number 1 pushes number 2, which way does it push it? To the left or right? You don't push something towards you. You push something away from you. So we're pushing number 2 to the right, away from number 1. I'm going to call that F12, the force of 1 on 2. Does that make sense? Now, 3 and 2 also have a force between them. 3 is negative, 2 is positive. Do they attract or repel? Positive and negative are going to attract or repel? Attract. They're going to attract. Now, attract means pull. So 3 is going to pull number 2, which way? Towards it, right? So 2 is going to be pulled towards number 3. It's going to go this way. I'm going to call that F32. Now, some of you are thinking, but wait a second, I don't get it, because there's a force on number 3 that's acting this way, towards number 2. 2 pulls number 3, right? Yes, it does. But we're not trying to find the force on number 3 right now. Okay, that's the next question. In this question, we're looking for the force on number 2. So let's look at what 1 does to 2. 1 pushes 2. Let's look at what 3 does to 2. 3 pulls 2. Both of those forces are to the right. Now I'm going to calculate both of those forces. This is the easy part, the force calculation. F12 is K Q1 Q2 over R squared. Make sure you sub in the absolute values of the charges. Don't put a negative 2.5 or anything like that. Just make them all positive. When we do that, we get a value for F12 of 3.596 times 10 to the 4 newtons. If anybody, by the way, needs me to show more for that, I can. I just don't want to show stuff that everybody gets, if everybody happens to already get that part. F32, we're going to do the same type of thing, KQ3 Q2 over R squared. The value of R here would be 0.02 meters. Gives us a value of F32 of 2.8094 times 10 to the 4 newtons. Now what? All right, our question to start off was, how does 1 affect 2? It pushes it. How does 3 affect 2? It pulls it. Now we've got both of those forces, the direction and the magnitude. Parker, what do I do with them? Yeah, this is physics 20 now, right? Remember in physics 20 when you had a free body diagram with multiple forces, you said F net is equal to the sum of the forces. Here we'd say F net is equal to the sum of the forces. The net force on number 2 is equal to F12 plus F32. Now in this one, you can afford to make a little mistake or to forget something because in the end they're both positive and you're probably going to get it right just by adding them together like that, right? But sometimes they're not both positive. So sometimes you really do have to pay attention to those signs. Okay? Make these both positive, add them up, and when we do that, we get a value of F2, the net force on number 2, of 6.41 times 10 to the 4 newtons. It is positive, which means it's to the right. Now let's take a look at number 1C, the net force on the third charge. Let's put our diagram down there again. This time, though, we have to draw a free body diagram on number 3. So there's two forces acting on number 3. One acts on 3 and 2 acts on 3, independently of each other. Don't try to put them all together. Don't try to treat it as one thing. Okay, do each part the way it should be treated, is independently of the others. 1 and 3 are opposite charges. Do they attract or repel? Opposite charges are going to attract. All right. Attract means push or pull. Pull. Okay, attract means pull. So number 3, we're not trying to find what happens to number 1, right? Trying to find what happens to number 3. Is number 3, if it's pulled, it must be pulled by number 1, which way? If I pull you, I can't pull you away from me. I pull you towards me, right? So number 1 is pulling number 3 towards it. I'm going to call this one F13, the force of 1 on 3. Now, 2 and 3, they're opposite charges as well. If they're opposite charges, they're going to attract. Now, that means 2 is pulled toward 3. 3 is pulled towards 2. We don't care what happens to 2. We care that 2 pulls 3 to the left. Now, if you calculate F13, it's KQ1Q2 over R squared. R is 0.045. How come? Yeah, you got to add those distances, right? The distance between 1 and 3 isn't either one of those distances that's given to us. It's the total of those two distances. That gives us a value F13 of 5.549 times 10 to the 3 newtons. And F23, that's a more straightforward one because the distance is simply one of those distances, 0.020 meters, gives us 2.8094 times 10 to the 4 newtons. Like, technically, there's nothing wrong with drawing the forces on 1 and 2. But if we're looking for the force on number 3, I would avoid drawing those other forces because it just clutters up my diagram, right? Clutter diagram, it just ends up being confusing. Sometimes I draw, like, say, like, look, 2 is pulled towards number 3, same as 3 is pulled towards number 2, right? But what do I always do with the force on number 2? Erase it, right? If I'm trying to find the force on 3, I don't want the other forces there. Even though there are more forces there, I don't want them there. All right, so we do our physics 20 thing. Say F net is equal to the sum of the forces. We'll say F13 plus F23. We add those up. What do we got to make sure we do for both of these? Or what should we do for both of these? Both to the left, so both should be, I'd make them both negative. Add these up, make them both negative. We get a value of negative 3.36 times 10 to the 4 newtons. What you really got to watch out for is if one is right, one is left. One is positive, one is negative. So we'll get number 3 now. Repeat question 1B with the third charge below the second charge. So my diagram for this one going to be similar to the first one, except that we have charge 1, which is 5 times 10 to the negative 5 coulombs. We have charge 2, which is 5 times 10 to the negative 5 coulombs. And then down below it, we have charge 3, which is negative 2.5 times 10 to the negative 5 coulombs. Our distances are the same, 0.025 meters, 0.020 meters. Make sure you have those converted to meters. And then we have to, well, find the net force on number 2. So to find the net force on number 2, just like the other 2 questions we've just done, we have to look at them individually. We have a force of 1 on 2. And we have a force of 3 on 2. 1 on 2, attractive or repulsive? What is it? Repulsive. And repulsive means the same thing as push, right? Okay, repel is a synonym for push. So 1 pushes 2. That means the force of 1 on 2 is this way. 2 on 1 is the other way, but it doesn't really matter to us because we're trying to find the force on 2. We actually know the value of F12 already from question 1b, right? Its value is 3.59, 6 times 10 to the 4 newtons. If you didn't already have that, you could find it using KQ1Q2 over R squared. What about F32? The force of 3 on 2. Do they attract or repel? Daniel? Positive and negative. They attract. Good. They attract each other. If they attract each other, then that means, what's the synonym for attract? Pull. So 3 pulls 2. 3 pulls 2 towards. Now 2 pulls 3, but I don't care about that one right now. This is F32. And the value of F32 was 2.89. Sorry, 2.8094 times 10 to the 4 newtons. And now we add these together, but we have to add them together vectorially. 3.596 times 10 to the 4. 2.8094 times 10 to the 4. And the resultant vector F is here. By the Pythagorean theorem, F is 4.56 times 10 to the 4. And theta is the inverse tan function of opposite over adjacent. That gives us 38.0 degrees. I'm not going to say south of east because talking about charges, south and east aren't really your frames of reference. So we're just going to say 38 degrees as measured from that positive x-axis. Yep.
Why don't we use like